So today we're going to look at section 2.4, which is on solving inequalities. We're mostly going to talk about linear inequalities. We do talk about like quadratic inequalities. Might maybe something you haven't done in the past, but I think that's the next section, 2.5. Okay, so today we're going to just focus on linear. We will look at absolute value because that is a type of linear inequality. Just a reminder what the four inequality symbols are. Less than, equal to, greater than, or equal to. These are both examples of inequalities. Okay, the one on the left, that's just a true statement. The one on the right could be true if we solve it correctly and get the answer. Yeah.
Is that kind of like identity and conditional?
Yeah, there's like a condition that would make this one true. As long as x is greater than 4, would make that one true. And this is just a true statement. Yeah. 3 is less than 8. So when we look at numbers for inequalities, we're usually not finding a single number that's a solution. It's a whole range of numbers that are like greater than a certain value or less than a certain value. And the idea is if you want to check if a number is a solution to an inequality, you take that number, you plug it in to your inequality, and you see if you get a true statement. Okay. So like, let's look at this one. Let's say I wanted to check if 5 was a solution for x. If I plug 5 in for x, what do I get on the left side? 15. Okay, is 15 greater than 12? Yeah, so 5 would be a solution. What if I plug in 0? What do I get on the left side?
0.
I get 0. Is 0 bigger than 12?
No.
So 0 is not a solution. Okay, so figuring out whether a number is or isn't a solution, you just plug it in and see if you get a true statement. Questions on it? So one special type of inequality is a conjunction. A conjunction, just a fancy way of saying it's an inequality with the word and. This is one way to write a conjunction. It says x is greater than -1 and less than 3. A lot of times a conjunction, it's like a between. X is between two numbers. Does anybody remember, I think we went over it, how you can write a conjunction by combining those two statements together and just having an x in the middle? Okay. Yeah.
Well, we'd start off by flipping the left equation so x is on the right side of that one.
Okay.
And next we'd do -1 and then, yeah, that symbol, which is the same as the other x, and then put another one of that symbol and then 3.
Perfect. So that's one way to combine that into a single statement, which I think I wrote down. Another way you could do it is you could reverse everything. You could put the bigger number on the left, the smaller number on the right, still keep the x in the middle, but then have your inequalities point that way. Logically, those two things are the same. I usually prefer this way. I do smaller number on the left, bigger number on the right. Both inequalities point to the smaller number. Yeah?
They both need to point in the same direction, right?
Yeah. Yeah. Is there any questions on how to take two separate statements and combine them into one? Or take something that's 1 and split it into 2? Like if I had something like this, let's say 4 is less than x, less than 12. How would you write that as two separate statements? Yeah?
X is greater than 12, and then x is less than 12.
Yeah, and just make sure you put the word and, which I think you said. X is greater than 4, and what was the second one?
X is less than 12.
Yep. Perfect. Now, conjunctions are the only kind of statements that can be combined together like that. If you have an or, like x is greater than 10 or less than 0. You can't combine that into a single statement. An or has to be written out. So what we're looking at here for an answer is really called an interval. And we've been practicing interval notation all year. Okay, really, I've been kind of throwing it in wherever we have a chance. To describe domain and range, we use it. But what we're going to talk a little bit more about is some different terms that apply to intervals. Okay, we're going to talk about an open versus a closed interval. And we're going to talk about a bounded versus an unbounded interval. Okay, this particular type of interval is called an open interval. Okay, it's also called a bounded interval. So the idea of an interval being bounded means that the smallest value and the largest value are not infinities. Infinity is unbounded, never stops. When you have a bounded interval, you have an interval that starts at a number and stops at a number. Going to infinity is not bounded. So there's really 4 types of bounded intervals you can have. Bounded just means that the endpoints of the interval are numbers. You can have what's called a completely closed interval. Closed means you'd have a bracket on each end. And what does that mean if I said like this? When you put the bracket on each end, it means, yeah, Jacob?
You can like include 2 and 12.
You can include the 2 and you can include the 12. Now comparing that to an interval like this, which I know it kind of looks like a coordinate, but you only can know from the context of the problem. That's an interval. And what does it mean when you put parentheses on the 2 and the 12? Yeah,
The 2 and the 12 are not included among the numbers that can be used.
right. And remember, you've got to think real numbers. So it's not like if you say between 2 and 12, okay, that really means between just 3 and 11. Well, you're missing all the decimals. Okay, if you can go from 2 to 12, that means like 2.000000001 up to 11.9 repeated. Okay, those are the numbers you could choose from. So we have what's called completely closed, completely open. What other kind of interval do you think we have? Said there were 4. Yep.
Probably one closed bracket and one open bracket.
Yeah. So we can have like a half open or half closed. So half open means one of them is a parenthesis and one of them is a bracket. The top one is half open on the right. The bottom one is half open on the left. So if I had to read an answer like to a homework question like this, just fix that. I might say that's the interval from 5 to 13, half open on the right. If I say half open, then you know the other end is automatically closed. Right, so those are the different types of bounded intervals. Bounded means there's a number. If it's unbounded, kind of already said it, but what symbol are you going to see? Yeah.
No, I was wondering. Bounded on the half open on the left is the top one.
Half open on the left would be the bottom one. Half open on the right side is the top one. So what are we going to see when an interval is unbounded? Yeah?
Infinities.
Right, you're going to see an infinity. Whether you have an infinity on one end or both ends, it's still considered unbounded. So I can add that one in. Those are all the types of unbounded intervals you could have. The first one is unbounded on the left side, closed on the right. The left one is unbounded on the right side, closed on the left. The second one is a completely open interval, unbounded on the left side. 5, infinity, it's completely open because it has a parenthesis on each end. And it is unbounded on the right. And the bottom one is a completely open interval, unbounded on the left and the right. So could you have, let me think, could you have an unbounded interval that is closed?
You can't, because
No.
you can never reach infinity.
Right. Unbounded means there's an infinity. When you put an infinity, that means you automatically need a parenthesis. Well, if you put a parenthesis, then it's not closed. So you can't have an unbounded closed interval. That wouldn't make sense. Could you have a bounded open interval? Bounded and open. What do you think? That's
Yeah.
Yeah. Bounded and open would just mean something like this. Bounded means it has numbers. Open means that it has parentheses on both ends. Yeah, you could have that. Right, so you just have to think a little bit about what those terms mean. But is there any question what bounded versus unbounded means, or open versus closed? Okay. And they also draw some pictures of these. So, like, say you wanted to draw a picture of this one. This would be a closed circle on 3, shaded left. That's more of a graphical way to represent it. This would be a, let's see, 0. That would be a closed circle on 5, shaded to the right. And you could draw them all out if you wanted to see all of them. This would just be the entire number line shaded, negative infinity to infinity, with an arrow going each way. Okay, but they show you the graph of each one of those on page 100. When you use a parenthesis, what kind of circle is that on the graph?
Open.
Yeah, open interval, open circle. Okay, so let's try writing answers different ways. What kind of notation is this? Well, just the notation in general. Yeah?
Wouldn't that be like a combined type? It would be -3. I forget which way it would be facing. Then x in the center, and then the same as the other one, but this one, the other one is right. It has a line below it, and then 5.
So we're gonna, yes, so that's how you're gonna write it as an inequality. But first I just wanna know what this thing is called. This is that's a hint, yeah?
Interval.
It's an interval. Yeah, this is interval notation. We're gonna change it to inequality notation. That's exactly what Jacob just said. This means all numbers between -3 and 5, not including -3. So x in the middle, -3 and 5. We can't equal -3 because that end is open, but we can equal the 5. So we put the equal to under it. So any question on changing interval to inequality? All right, let's try this one. The interval from -4 to infinity. How would you write that as an inequality? Yeah.
-4 less than or equal to x, x less than infinity.
Okay, is there anything you could simplify there? Because you don't really need to say something, because it's automatically always true, something you just said.
Oh, x is going to be greater than or equal to -4.
Yes, x is greater than or equal to -4. If you say it's less than infinity, that's okay, you can. But everything's less than infinity. That's automatic. So really all I would say here is greater than or equal to -4. So, the letter that you use, x, y, we're not talking about domain and range specifically, so the letter isn't important. Just use whatever letter they ask you to, or whatever letter you want if they don't ask you. Okay. How about this one? The closed interval, closed bounded interval from -8 to -3. How would we write that as an inequality? Dex.
-8 less than or equal to x less than or equal to -3.
And I talked about a different way you could write that if you flip the -8 and the -3 and you flip the inequality signs. But that's perfect. Okay, questions on that? Okay, so that's interval to inequality. Now, let's take inequality to graph. Okay, let's try that. So you'd already have a number line on edge elastic, so I'll kind of take care of that part. And the first thing we have to decide is what kind of symbol would we put on the tube? Yep. Closed circle. And we need to do one more thing. Yeah, Joe?
Arrow to the right.
Yeah. Arrow to the right. So that's x is greater than or equal to 2 as a graph. You should be able to change between all of these, graphs to inequalities to intervals. Okay, all different ways of representing your answer. How about this one? First, tell me the symbol and where to put it. Yep.
You put a open circle on 5.
Okay. So that's the symbol. And now I have to do one more thing. Oh, Brian, what do I do next?
Arrow to the left.
Yeah, I'm going to do an arrow to the left. And that's that. Okay, questions on that one? All right, let's try this one. First of all, what kind of inequality is that one?
Conjunction.
That's a conjunction because it's been combined together. It's the only kind of inequality you can combine. So let's set up my number line. Okay, and how would I go about graphing this one? Because this is a bounded interval, so it's a little different than graphing the unbounded.
So put a closed circle over -1,
Okay, so we're going to do the closed circle over -1.
and then an open circle on 3,
Okay, open circle on 3.
and then shade in between.
Because it's a bounded interval, we shade between. We don't have an arrow that keeps going in one direction. Questions on that? It's an edge elastic. You'd be able to click. There'd be 4 different tools to click. There'd be the one with the 2 closed circles, the 2 open circles, open on the right or an open on the left. And when you click it, you just drag it up to the number line, and then you can drag these start and stop points wherever you want. Was that the last one? Yeah. So when we're solving inequalities, we do the same steps that we use when solving equations, except there's one thing we have to be careful about. What's something you could do when you solve an inequality that you need to be careful? Yep, Jake.
I don't remember what for, but if you flip the sign.
Okay, there is a time when you need to flip the sign. Does anyone remember when you have to do that, Joe?
Dividing.
Yeah, when you're dividing, can you be more specific?
By negative.
Okay, dividing by a negative. Yeah.
The same rule is applied when multiplying by a negative.
Yeah. So if you multiply or divide by a negative, you have to flip the inequality. That's true no matter what kind of inequality you're solving. If you're solving a conjunction where the x is in the middle, yep, you got to do it. If you're solving absolute value problems with inequalities in them, yep, you got to do it. Anytime you multiply or divide by a negative, you have to flip the inequality. Other than that, you solve it just like you would a linear equation, except it's the equal sign is replaced with an inequality. So what would be my my first step on the left-hand side?
You would be distributing the 3x and then -1.
Yep. So distribute that 3. So you get 3x, and I'm going to do two things here. -3 plus 2. Michael, what's -3 plus 2?
That would be -1.
-1. Yep. Okay, so there's our first step. Jack, what would I do next?
You add the 1 to both sides.
Okay, and what else can I do at the same time?
Can you add the 3x to the other side? Or subtract the 3x from both sides?
You could, but the problem is it's going to do with 0 on one side.
If you were going to try that, it would have been better to subtract the 6. But for this, you've got to get the x on one side and then the other one onto the other.
Yeah, we want to put the x's on one side and numbers without x's on the other.
Is the x minus 1 in parentheses?
It was, yes.
And don't you have to distribute it first before you can remove it?
We did, yeah.
But then
We distribute it and
simplify
combine like terms.
Then wouldn't that one be a 3?
So you get -3 and then +2, which is -1. So what I would do here is if you're going to put the numbers on the right side, I would put all the x's on the left, which is fine. But we got to put everything on one side that has a variable, everything on the other that doesn't. Okay, so now that gives me -2x is less than or equal to 7. Okay, now, Max, what's my last step?
Getting rid of the dividing by
Yep, and because we're dividing by a negative, what do we want to make sure we do? Yep, flip that sign right away. And we get x is greater than or equal to -7/2. Which you can leave your answer as an inequality. You could graph it, or you could write an integral. I'm just going to leave it like that. Question on that one? So if you forget to flip it, then you're really writing exactly the opposite of what you want as the answer. So you've got to remember to flip it. Because we divided by a negative. Okay, it's a couple different ways we can solve graphing inequalities on the graphing calculator. The first way, and this kind of ties in with what Jack was doing on the last problem, you put everything on one side, and then we're going to calculate a root. Now, the answer is not the root. The answer is everything that's usually greater than the root, or greater than or equal to, or everything less than or equal to the root. But the root is just the number that you're going to use, and then you have to put your inequality symbol in. And the way we figure out where to put which way the inequality symbol is going to go is, well, it depends on, are you looking at a graph that's less than 0? Or are you looking at a graph that's a greater than 0? If something's less than 0, it's going to be a negative value. So when you look at the graph, it's going to be under the x-axis. If you're looking for the part of the graph that's above the x-axis, that's a positive value, and you need to use a greater than. All right, so we just have to look at the graph and figure that part out. But it really is going to amount to whether you want to have the part below the axis or you want to have the part above the axis. All right, so let's try this one. And I know it's very simple. We could solve it without a calculator. But let's get everything on one side of the inequality. Okay. How would I get everything on one side? Oh, Rory?
Add 1 each side.
To get everything on one side, I don't think that would be the quickest way to do it.
I would subtract 2.
I would subtract 2, yeah, because we're going to calculate a root. If we were going to solve it algebraically, then yes, I would do what you just said. So 4x minus 1, minus 3 is less than 0. Okay, let's graph it. So we're not going to graph the inequality symbol. We're really just graphing 4x minus 3. And what we're looking for is where is this graph below the x-axis? Where is it less than 0? Okay, so you really have 3 things here. Let me show you. Okay. First of all, you have where it is less than 0. You have where it's more than 0. And then you have where it is exactly 0. We are looking for where it is less than 0. So I'm looking for the red section. So what I'm going to do is find where it's exactly 0. And then I'm either going to want all the values that are bigger than that, if that's the section I want to be in, or I want to pick x values that are smaller than that to put me in the red section. We have to decide which section we want to be in. But you should know which section you want to be in because we want to be under the x-axis. We want to be below 0. Okay, so let's find where we are exactly 0. Second calc, 0. Pick a point left, right, and do your guess. So we are exactly 0 at 0.75. So now, I want to know where my graph is under the x-axis. So would I want to pick values that are less than 0.75 or more than 0.75? Yeah.
Less than 0.75?
Yeah, less than 0.75. Picking values that are less than 0.75 is going to put you on that section of the line. Yeah.
How would we draw that? Well, not draw that, but if it, like that elastic thing where it shows the shaded graphs, which half would be shaded?
Oh, you'd just be typing in this.
Yes, but like what questions would be where you have like one half the graph shaded, the other is not, like above the line or below the line? But how does that work?
So that's usually when you're shading, like when you do like a solid line or a dotted line. That's a little bit different than what we're doing right here.
Okay.
I think we did talk about that at one point. That's usually when you have 2 variables, like y is less than 3x plus 5. Then you graph it like it's y equals mx plus b and then shade above or below. But you won't be doing that in this.
Okay.
You're just solving an inequality with 1 variable, not 2. Okay, so that's one way to do it. And I know, very simple. You probably could have just done it quicker in your head by adding 1, dividing each side by 4, and you get x is less than 3/4. But we're going to eventually do some that aren't as easy to do, okay, in our head. So the second method you can use is don't rearrange it to get 0 on one side. Leave it the way it is. And put 2 things in. Put 4x minus 1. Put that in y1. Put 2 in y2. Now I did the 4x minus 1 in blue. I did the 2 in red. And what we're looking for this time is where the blue graph is under the red graph. All right? It's going to be the same answer. But we're looking for where the blue is under or less than the red. Let's hit graph. Well, the first step to figuring out where one is above the other is figuring out where they're exactly the same as each other. Then we can decide where to go from there. How do I see where they're exactly the same?
Second calc intersect.
Yep, second calc intersect. So they are exactly the same when x is 0.75. Now, I want the blue to be under the red. So to make that happen, would I want to pick values below 0.75 or above? Below. If you pick values below 0.75, the blue graph is down here, the red graph is up there. So the blue graph would be under the red. Yep. Let me just move this up so you can copy what's under there. So I asked you what we had to do, and someone said you're going to do the intersect. And then determine if it's everything below the intersect or everything above for the x value. In this case, it was below. So it's two ways of really doing the same thing. You can either do it as an intersect, or you can put everything on one side and do it as a root. So example 5 is the same problem as example 4. It's the same question twice, just doing it a different way. Any question on that? And again, not one I would ever even use a calculator for because I can do the algebra in my head faster. Okay, so a compound, or like a double inequality. There's two ways to solve this kind of problem. One is to try to get the x alone in the middle. If you're going to solve it that way, then whatever you do to the middle, you have to do on the left and on the right. Now, when this method doesn't work, is if you have something like this. Okay, in that kind of compound inequality, no matter what you do, you are never going to be able to get an x alone in the middle. You could say, well, what if I just minus 2x? Yes, but you have to do it here, here, and here. So no matter what you do, you'll never be able to get the x alone in the middle. Unlike this one, you can very easily get x alone in the middle. And that's because there's only one x in the problem. If you have more than one x, the only way to solve it is to take it and split it apart into the two original problems it was before it was combined. So in a problem like this, you would have to solve -8 plus 2x is less than 3x minus 4. Do that off to the side. And then 3x minus 4 is less than 5. And do that off to the side. So you have to go about it a little bit differently when you have x's in multiple spots. But the key is just split it back apart into what it was before you combine it. Okay, I'm going to show you a couple where you can get the x alone in the middle. Just remember, whatever you do to the middle, you got to do the left and the right. Okay, so let's try this one.
Couldn't you solve a function an inequality that has x on both sides algebraically?
Yes, that's where you have to take and split it apart into two problems if you have x's in multiple spots.
Okay.
So you'd write the left side in the middle, there's one, and then the middle and the right, there's the second one.
Okay.
Yep. This one, you're going to be able to keep it all together, though. We can solve it just like it is here.
Okay.
What do you think the first thing I would do here is to start to get x by itself in the middle?
Multiply everything by 3?
Yeah. So the first thing would be times 3, times 3, times 3. If you multiply by a negative in that step, flip the sign. All the signs. Okay, but we didn't. We just multiplied by 3. So Lily, what does that give me on the left side?
Negative 9.
-9. Okay.
2x plus 5.
And then, yeah, in the middle is 2x plus 5. And on the right side, Max, what do I get there? Yep, we get 15. Okay, so there's the first step. What would be my second step to get x along the middle, Joe?
I would subtract 5.
Yep. Subtract 5. And we're not multiplying or dividing by a negative, so no flipping the sign. And what do you get, Joe, if you subtract 5 from everywhere?
Negative 43 is less than 2x. Is less than or equal to 10.
Yep. And my last step to get the x isolated in the middle. Mike? Yep, and that's a positive number, so nothing we need to flip. And can you tell me the final answer?
Negative 7 x, or negative 7 is less than x, and then 5 is equal to or greater than x.
So what symbol comes right here?
Greater, less than,
Less than
or equal to
or equal to
5.
5. Yeah. Good. So there's your answer. Now, if you had x's in multiple spots, the first thing you would have had to do is write -3 is less than 2x plus 5 divided by 3. That's the left in the middle, and solve that problem. Then you would have written down 2x plus 5 divided by 3 is less than or equal to 5. And you solve that problem separate. If you did this problem that way, you'd get the same answer. On one side, you'd get x is greater than -7. And then on the other side, when you solve it, you would get x is less than or equal to 5. Okay. If I can keep it all together, that's how I do it. But that only works if there's just a single x in the middle. Question on that? All right, so let me see where we're at. All right, let's try this. We'll at least set it up. It says to think about the rectangles you have where the length is 1 unit more than twice the width. I don't know if we're going to need to translate that, but let's just translate it anyway. How would you write down the length is 1 unit more than twice the width? Yeah. Yeah. I'm not sure we'll need that, but I'm guessing we probably will. It says find an algebraic representation of those rectangles with a perimeter less than 100. So we're also going to need the formula for perimeter of a rectangle. What's the formula for perimeter of a rectangle? Yep.
2 times width plus 2 times length.
Yep. So 2 times the width plus 2 times the length. And in this case, they're telling me that the perimeter is less than 100. Okay, well, there's the perimeter, 2w plus 2l. So change P to 2w plus 2l. Perimeter is less than 100. But I can replace something here and get that all in one variable. Which letter can I replace in the bottom? Yeah, the L. I can change L to 2w plus 1. So the formula you would set up is 2w plus 2 times L, it's 2w plus 1, is less than 100. So there's the inequality you would solve. Distribute it out, combine like terms, and then when you're done, you might get an answer like the width has to be less than 15 or something. Okay, but I think at least setting that up, that's the harder part than solving. Any question on how we set this up? It would be better to make this 6w plus 2 is less than 100. That's what you should do it. and then solve. Okay, so yesterday, one of the last things we talked about was absolute value equations. Okay, I'm going to do the same thing, and the steps are almost the same, except I'm going to talk about absolute value inequalities. So just like yesterday, when you want to solve an absolute value inequality, you need to make sure the absolute value is by itself. Is this a absolute value inequality where the absolute value is by itself? Sense?
Yes. No. Oh no, I didn't
Is there-
agree.
Oh, okay, yeah. Is there any? As I say, is there anything outside these bars? The answer is yes. So you'd have to divide both sides by 3. Now, if that was a negative, and you divide both sides by -3, you need to flip that inequality. Okay. So first step is make sure the absolute value is by itself, and then split it into 2 problems. The first one, this is exactly what we said yesterday. You basically just take the bars out of the problem and solve that. So if this was your problem, it would be 2x plus 4 is less than or equal to 5. Now, for the second one, what did we do to the number on the other side? When we solved it as an equation yesterday to get that second equation.
So you can remove bars and set to equal to x. So like you need to solve for x.
So yep, we're going to solve for x. So the first one, we get rid of the bars. And then what do you do for the second one? Yep.
Could you just put a negative on the other side?
So we got rid of the bars and we made the number on the other side negative. But with inequality, there's one more step. When we make something on the other side negative, we also have to, we have to flip the sign. So that's the extra step. So the second inequality, you take away the bars, you make the number on the other side negative, but you also have to flip the sign. And then you solve each one of these inequalities. Now, when we solve them, we have to be careful because we have a choice when we write the final answer. Yeah.
After as, what does that say?
Original second inequality is the same as the original, except we remove the bars, flip the sign, and change the number on the other side. Negate it. When we write the final answer, there's 2 words that we can use. We can either put and, or we can put or. It makes a big difference, okay, which one we put. To figure out which one you put, you go back and look at the problem that has the absolute value isolated. Okay, so if you had to do a step to get to this, fine. But once you get to this step, look at the step where the absolute value is isolated. If the original problem had either a less than or a less than or equal to, once you isolated the absolute value, you use the word and in your final answer. If it had a greater than or a greater than or equal to, we would use the word or. So the way I remember it is if it's a less than, if you say it that way instead of less than, say less than, land, the word land, or if you have a greater symbol, instead of saying it like greater, if you say it as greater is an or. Greater or less than is an and. And that's a step we didn't have to do yesterday either because we had an equation, not an inequality. Okay, so let's try this. Before I even break it up, is this going to be an and problem? Or is it going to be or? Yeah? This is an and. That's a less than symbol. So we're going to have an and. So a lot of times what I'll do is I'll just pick the word and right away. A test, I might have a drop-down box. You pick and or you pick or. What's going to be my first inequality that I solve? How would I set up the first one? Yeah. So, x minus 3 is less than 3. So just take the original problem, get rid of the bars. And what about the second one? Two extra things you got to do. Yep.
X minus 3 is less than -3. And you just flip the sign.
You got to flip the sign. So x minus 3 is greater than -3. So solve this. You get x is less than 6 and x is greater than 0. And that makes sense. You can pick a number that's smaller than 6 and bigger than 0. If you didn't flip the sign, it might not make sense. So sometimes you can kind of tell.
Yeah, even once you like do it, you see that they're both going in the same direction. Like if that, it would say x is greater than 6 and x is greater than 0. Like those, you graph it out.
Yeah, they'd both be, it'd be like an overlap. They'd be pointing the same way, starting at different points. Yeah. Usually with a conjunction here, we're going to end up with a between. Okay. Right. Any question on that one? That's that one. Okay, so one application we can do of an inequality is that if I said to you, I'm thinking of a number in my head, and the number I'm thinking of is less than a certain number of units away from something. Like if I said, okay, I'm thinking of a number that's less than 2 units from 5. Okay, what does that really mean? Well, here's 5. And if I'm thinking of a number in my head that's less than 2 units away from 5, that means I could be thinking of a number as big as 7 or as small as 3. Anything between 3 and 7 is 2 units, less than 2 units away from the number 5. So here's how you can write an inequality to represent a sentence like that. So this is translating a sentence to an inequality. Okay. Let's try it with actual numbers. Let's say x is within means less than, same thing. X is less than or within 4 units of the origin. So let me write up above what number would go where. So x is less than or within 4 units from, well, I'm from the origin. So what number is that? 0. So in this case, you're just filling that inequality in where a is 4 and b is 0. And when you write that down, it represents that sentence as an inequality. So what would it look like when I write it down, filling in what I said?
So you want to write both or just?
I just write this. Just gonna write that.
You write x minus 4.
Well, absolute value, right? X.
Alright, then x plus 4. Oh, I'm sorry. What it is, it'd be x minus 0 is less than 4.
Yeah. That's the inequality that represents being within 4 units of the origin.
I was thinking b was 4.
Yeah, no, B is what you're away from. A is how far away you are from it. So this is what you are away from, and then this is how far from it. let's try it. Let's try another one of those. Let's see if I can get that on the board. Yeah. Let's say I wanted to represent being less than 3 units from 2. Start out like this, x minus and less than. What are we measuring the distance away from at this point? What's our point that we're going to be away from? Yeah? 2. We're measuring the distance from 2. And how far away do we want to be from that? Up to 3. If you solve that, you'll get, we'll just think about it common sense. What's 3 units away from 2? As big as what?
Well, this is less than 5. Can it not be equal to?
Technically, it would go right up to 5. And it would go as low as
Negative
1, not including. So it would, you'd get an answer that x is greater than -1 and x is less than 5 if you solve that. Yep. So it's a little tricky with the wording, but if you break it down to that formula, just that's what you want to be away from. That's how far away you want to be from. And that's the inequality. Skip that, skip that. And the last one, well, it was solving this. I'm just going to give you a hint on it because there is one like it in the homework. If you want to know when a fraction is greater than 0, well, there's only 2 kinds of numbers you can really divide here. You can divide positives and negatives. If you want to know when something is greater than 0, what kind of numbers do you have to divide to get an answer bigger than 0? You could divide a positive by a positive.
Yeah, or like the same.
Or you could divide a negative by a negative. Only one of these applies here. Which one of these situations would have to happen if you're going to divide these 2 numbers and get something bigger than 0?
Has to be positive.
Has to be the positive over positive. Why not this one? Yeah?
Because the top isn't negative.
Well, it could be if I let x be -10.
Or because you're getting undefined.
Because what?
Would you get undefined?
You got to be careful about plugging in 2. That's another issue. But thinking of something else, yeah?
Absolute value.
The absolute value, the bottom is always going to be a positive. You can't control that. No matter what you do, don't plug in 2 though, because that'd be undefined. If you plug in anything except 2, the bottom is always a positive number. So if the bottom is always going to be positive, all you have to worry about is when is the top also going to be positive, and you'll automatically get an answer greater than 0. So if you can figure out when this happens, that will solve the question. Whenever the top is a positive number, the bottom is always positive. So in this case, it would be x has to be greater than -3, but not what number? But not 2.
-3.
X is greater than -3, but not the number 2. So anything you want that's greater than -3, but not the number 2. And we can look at another one like that tomorrow.
Can it be greater than or equal to?
No, because this was a greater than.
Okay.
If it had the equal to under it, you could have done the equal to. Okay, so that's the homework for tonight.
Isn't it